So first of all, good morning. Thanks for coming to this JAX-RS and CDI bike, the reactive bridge session. So before we start, and very quickly, a few words about us. So my name is Delabassee. I work at Oracle in the organization that is responsible for Java SE, Java E. We are also responsible for open source projects such as Glassfish, Jersey. Our org is also responsible for commercial products such as WebLogic Server and other cool stuff like the FN project that was just open source during the keynote. Before that, I spent 10 years at Sun, and before Sun, I spent 4 years working on Java. So basically, by looking at the evolution of my haircut, you can clearly see that I've been involved in the Java space since quite some times.
And my name is José. I live in Paris area. I provided here some links. We're going to talk quite a lot about CompletionStage and completable future and the interaction with the JAX-RS API. And if you check my YouTube account, I have several talks, especially on the topic of the CompletionStage stuff. I'm also an author for Pluralsight and a proud member of the Paris Java user group.
So this was me some months ago at JFocus, a conference in Sweden where I was giving a talk, and someone in the audience tweeted that it's not a real conference unless you read Oracle safe harbor statement at least once. So please enjoy. Now, today we're going to talk about future, but future as in the concurrent util package, not future as in future stuff that we might do in a product. So we're on the safe side. So we can basically ignore what is being said there. Next is our personal disclaimer. Learn French, it's much easier than understanding French-speaking English. Now, I'm not French, but don't tell José.
Aren't you?
So let's first set the stage. So today we're going to talk about reactive. Now, if you look at the reactive manifestos, it defines things like elasticity, like responsiveness, async message passing, those kind of things. By reactive, in the context of this presentation, we really mean reactive as the ability to respond efficiently to some kind of event that are passed. So basically, we will take some of the API that are part of the Java E platform, like JAX-RS and CDI2, and we will kind of extract them from Java E, and we will use them in a pure Java SE context. Having said that, all the patterns that we're going to present today will also perfectly work in a pure Java E environment. And the idea is really to look on how we can leverage those API and the Java SE CompletionStage API to basically have this reactive capability to your application. And once you will get the patterns that we will present, once you will apply those patterns to your application, at the end of the day, your application will obviously be using asynchronous message passing capabilities. But at the end of the day, they will scale more and they will be more responsive. So that's really what we mean by reactive today. So the first API that I want to discuss is the JAX-RS API. We will spend a fair bit of time on JAX-RS because basically our session is based on how we can better use JAX-RS using this reactive ID. So we have just released JAX-RS 2.1 along with Java 8. JAX-RS 2.1 comes with different enhancements like support for server-sent events, support for JSON-B, and so on and so on. We're going to talk. Basically, we'll skip that today. We will focus on one specific feature that has been added in JAX-RS 2.1, and that is a new reactive invoker. So to explain what that reactive invoker solves, let's first look at the JAX-RS Client API that we have in JAX-RS 2. So in JAX-RS 2, we basically have an API that we can use to easily consume a remote REST endpoint. And the way it works, well, first you need to have a client object. So that's basically a client-side container that you can use to consume a remote endpoint. You get it through this method called, so client builder new client, and you will get that client container. It's convention over configuration. I haven't specified anything, but obviously I have the ability to configure that if I need to. Once I have my client container, I need to construct a web target. A web target is basically some kind of glorified URL. So it's basically where on the network is my remote REST endpoint. I have my web target, so next I need to construct, based on my target, my request. So that's basically the request that I would like my client-side container to issue. And then we'll see at some point in time, I will issue that request. So basically, I will tell my client container to issue that REST request. So in this case, for example, we see that this is a GET request. It could be a POST request, it could be a DELETE request, it doesn't really matter. And you see that what we are expecting to get in return is a forecast object. And given that we have this client container that we can use multiple times, obviously we need to make sure that we close it. It implements the auto-closable interface, so that's one easy way to deal with that concern. So in JAX-RS 2, we have this client API. We have this Fluent API. You get a client builder. From the client builder, you get a client. From the client, you set the web target. From the web target, you construct the request. And finally, you invoke the request to get a response. Now, if you look at the bottom of the slides, we have a typical request. So we have the ability to set the headers and so on. It doesn't really matter. But what is key here is the fact that the GET is blocking. So the client container will issue the request, and basically my method will block until we get the result from the remote endpoint. Now, in JAX-RS 2, we also have asynchronous capabilities. So if you don't specify anything, that will be a blocking request, so a synchronous request. But if you look at the bottom of the slide, I have this async method. So this is basically to tell to the JAX-RS client container that I want to use the async invoker. And if you look at the return type of that request invocation, we don't have a string anymore in this case, but we have a future of string. So that basically means that we have an object that we can use in the future to basically get the result from the request invocation. Now, if we do that kind of request, we will basically have a non-blocking call. So our method will return right after the GET, right? But you know that to access a future object, we need to do a GET. And the issue is that that GET is blocking. So with that, we haven't solved anything. We have just delayed the problem. We still have a blocking behavior, and obviously we don't really want that. The issue is that if it takes forever for the remote endpoint to send the result, well, our code will be blocked forever. So what you need to make sure is you need to make sure that you at least have a timeout, right? So if it takes more than 5 seconds, in this case, we'll have an exception. So our code will be blocked at worst for 5 seconds, which is not ideal, but it's better than be hanged forever. Now, we can also do these kind of things. So instead of directly accessing the future object, we can check if there is some result in that object. And if there is, we can access it. So it doesn't really solve the issue. And what you also need to make sure is that you set some timer, but now at the JAX-RS level, to make sure that, again, if for some reason you don't get a response from the remote endpoint, your code is not hanged forever. Now, the good news is that in JAX-RS 2, we have a facility that allows us to basically work around those blocking issues. And that's an invocation callback facilities. So it's basically an interface that has 2 methods that need to be implemented, completed and failed. And the names are pretty obvious. So the completed callback will basically be invoked when we have the result from the remote endpoint, and failed will be invoked if something goes wrong. So it works like this. So this is a normal JAX-RS request. I'm using the async invoker to tell to my client container that this is indeed an async invocation. And now, when I do the request, I pass it an invocation callback. Invocation callback that needs to have 2 callbacks. Completed to deal with the response that will be sent at some point in time by the remote endpoint, and failed if something goes wrong. Now, let's put that into perspective. So this is a typical microservices scenario where we have one travel agency services that need to consume multiple backend services. In this case, we have 4 backend services, and the idea of the scenario is that we have a user that comes in, The travel agency services will invoke the customer services to get the history of that users. Once we have that, we will invoke the destination to have a potential destination that we can suggest to that user based on its travel history. And for each destination that we're about to suggest, we would like to add some weather information and some quoting information. So the user comes in and the travel agency services will be the client of those 4 backend services, and it has to answer with like 5 or 10 destinations with all the details like forecast and pricing for that given users. Now, this is pretty obvious, but if we put some cost on some weight on the request invocation that we have to do, we clearly see that if we go through a pure blocking serial approach, it doesn't really make sense. It will take like 5 seconds to return those results. So that's clearly not something that we want to do. On the other hand, we see that we can optimize our orchestration workflow between the different services invocations. So for example, the first services that we need to invoke is the customer detail services. Once we have that, we have to invoke the recommendation destination services. But once we have the destination to suggest, we can invoke in parallel the quoting services for that given destination and the weather forecast for that same given destination. So if we apply, again, the cost of those requests, we see that at the end of the day, we should have something that is way faster. Now, let's look on how it can work with the JAX-RS 2 API and with this invocation callback facility. And let's simplify the scenario a little bit. Let's just pretend that we have only 2 services to consume, the destination services and the weather services. So, how we would write that code using the JAX-RS 2 API. We have a first request that basically gets the destination, the recommended destination. It's an async request, right? Given it's an async request, we have to pass it an invocation callback. An invocation callback has 2 callbacks. The completed, that's the callback that will be invoked when we have the result. So when we have the destination, what are we doing? Well, we'll basically go over all the destinations that we have, and for each destination, we will do another request, another REST request. It will be an async request. So that means that we have to pass it an invocation callback. Invocation callback with 2 callbacks, including the completed that will deal with the result. So in this case, we just get the forecast information from the remote endpoint, and we add it to a map for that given destination. And obviously, we have to implement the fail callback for the 2 types of requests that we have. So I guess that you see where I'm going to. This is basically going to be a callback hell. And I had to simplify my scenario to 2 services just to try to make it fit on 2 slides. The original basic scenario had 4 services. So that kind of code is difficult to write, debug, and maintain. So clearly, it's not something that will work over time. And that's the issue when you have services with dependency. So the good news is that, and that's the point of this talk, in JAX-RS 2.1, we have a new reactive invoker. So you see at the bottom of the slide, we have this Rx method that is basically used to tell to the JAX-RS client container that we want to use an asynchronous reactive invoker. And if you look at the return type of that invoker, it's not a feature object anymore, it's a completion stage of the response type.
The main difference between the future and the completion stage stuff is that the completion stage is Java 8, so it's kind of modern API, whereas the future stuff is Java 5, 2004, so it's almost it's an older API so far. Completion stage is an interface implemented by Completable Future. It's a full API. The idea is really to take a task, and this task is going to be modeled as a Lambda, since we are in the Java 8 world. And this task is going to be executed asynchronously in another thread than the calling thread by default. We can pass an executor service, by the way, to tell the API, hey, you should be executing this task in this given executor service or in this given thread. The nice thing is that given a completion stage having the responsibility to execute a task, we can chain other tasks on it that are going to be executed on the completion of this completion stage, which is not the case with the future API. We cannot do that in the future API. So the idea is really to create a chain of asynchronous tasks. Here CS1, which is my first completion stage, that will trigger 2 further tasks, 21 and 22. Then 22 does not trigger anything. 21 triggers 31. And on the other side, I also have another task independent of those, CS32. And both 31 and 32 are going, once they are both completed, are going to trigger CS41. So this is basically the kind of graph of task I can create using this CompletionStage API. This is the big picture. Now, this CompletionStage API is quite complex. There are a lot of methods in it. Also, a lot of methods in the completable future stuff. It's a bit cluttered to understand. It's not easy to understand it at first. What we are going to do here is really to present a simple pattern to solve the problem that we have set up with David, that is triggering queries on REST services given the list of destinations we have. So let's go. The first step is to query the forecast backend service once we have the list of destinations. Remember, we are a customer, we are buying some kind of travel somewhere, and the website we run wants to push us other destinations that we may be interested in. And along with those destinations, we want to add 2 information, the forecast for this destination and a quotation, a price for that destination. And everything is distributed among several REST services. So given a destination, a known destination, the first thing I can do is query the forecast service using this kind of pattern. Most of the time, since it is a REST service, what I will be getting is in fact a JSON object. So once I have this JSON object, sometime in the future, remember this is a completion stage, what I must do is unmarshal it using some basic JSON builder code just like this. So this is a function that is just taking a JSON object and unmarshalling into a forecast object that I can use, right? So how can I trigger the execution of this function once this completion stage is completed? Well, I have an API for that. Query forecast, this is my completion state object, then apply unmarshal forecast. This will trigger, this then apply trigger method call will trigger the unmarshalling of the JSON object once it is available, that is sometimes in the future. All right, so I need to wrap that into a method that takes a destination. This destination will first trigger a request on the forecast REST server that will return a JSON object. This JSON object will be unmarshaled by the unmarshal forecast object. And then once I have this forecast object, the idea is to set a special property of my destination object with this forecast object, thus making this forecast available directly in my destination bin. So basically, this takes a destination object and does not do much with it. It does not return a new destination object. It just sets a property inside this destination object. So this is a function that takes a destination object, and since there is a then apply, that is the triggering of the unmarshalling, and a then accept, that is the triggering of the setting of the property inside the object, it returns a completion stage of void. The building of this function doesn't do anything. It's just a declaration of some kind of a method in a pipeline. So it returns immediately. But of course, the task itself will be executed sometime in the future. So once I have that, I can do the same with quotation, for instance, following the exact same pattern. So if I have like 3 or 4 property to set in my destination object, querying 3 or 4 REST services, corresponding REST services, I can multiply this number of functions. This returns a completion stage of void, and this is what I am going to use in the future. So what does my travel service will begin to look like? I can create this populate destination function that basically takes a destination and will set the different properties of this destination object using the result of the querying of the REST services. For that, I am going to use this static method from the completable future class, completable future all of, that returns a completion stage that I can make that I can get as a completable future using the toCompletable future method. Then this completion state object, this all of object, will be completed once all the past completion stage are going to be completed themselves. So if I have 3, 4, or more properties to set up, all I need to do is just scale this pattern by passing more completion stage to this all-of method, which is something I can do. Now, the nice thing is that if I have many threads in my executor service that is going to execute that, all those requests are going to be executed in parallel. Suppose I have 50 properties to set up. If I have 25 threads, then every thread will handle probably 2 properties to set up. But if I have more than 50 threads, every query and property setup will be handled in its given thread, thus making things much faster, as David showed in the big picture image about the organization of the overall system. So this is something that takes a destination and will populate the properties of that destination using the querying of the REST services in an asynchronous way and in a parallel way. Right. So this destination, now I need to get it from somewhere. So let us do that. What I get, in fact, from the REST service, from the first REST service, is a list of destination. So what I need to do now is for each of those destinations, apply this function one by one. Now, this is, of course, the nice job for the stream API. So I can just stream this list of destination. For each destination, apply this populate destination function that will return a completable future that will complete once all the properties of that precise destination are going to be set up. All right? So I have, in this stream here, I have one completable future per destination, each completable future corresponding to as many completable future I have for properties I need to set. Okay? So that may be a lot, really. If I have 50 destinations and 3 properties to set, that will be 150 completable future in the end. And I'm going to put all these completable future in an array. Why? Because what I'm interested in is the time at which all those completable future will complete. And for that, I'm going to use an all-of static call once again. And for that, I need an array. So I'm going to put all the results of this stream mapping in an array. Okay, so how can I set up that now in my REST service of JAX-RS? I have 2 patterns, in fact, for that. First, populate destination that returns a void and takes an async response, and this is a JAX-RS 2.0 pattern. I first query my destination REST service that is going to return me a list of destination after some JSON-B unmarshalling of my JSON array object. We'll leave that aside. Then I can get my completion stage by composing this completion stage that will get the list of destination with the function I just wrote in the previous slide, right? Using the then compose and the all-of. Remember that this populate destination returns itself an array. Okay? So this completable future all-of will be completed once all the destinations have been populated with their properties I want to set. This returns an updated destination completion stage, and I need to pass the payload of this completion stage to the async response, because this is the way this pattern works in JAX-RS 2.0. So I need to switch this completion stage into a completable future, and since completable future is an extension of a future, I can call the get method with all the precautions that David showed you, timeouts and stuff like that if the process takes too long. Now, this is, I would say, the old-fashioned way of writing things. Since I am in a JAX-RS 2.1 world, I can also directly return this completion stage, and the opening of this completion stage will be handled by the JAX-RS 2.1 API directly. All right, so this is the big picture on a, I would say, a real-world example, a non-trivial example to handle this CompletionStage API. Now, what is happening if I have an exception at some point? I am querying REST services. They might not be here. I am unmarshalling some JSON objects. This could raise exceptions. The idea in the CompletionStage API is that if at a given point of my chain of tasks an exception is raised, then all the downstream completion stage will be also raise an exception. So it will kind of break all the process if I have an exception at some point. But I have methods to handle that, which is nice. The first one I have is the exceptionally method that returns a new completion stage, and I can decide if this completion stage is in error itself or not using that. Okay, so let us try to do something smart with exceptions. I know it's not easy, but hey, we can at least try. I also have a handle method that takes both the result and the exception. If there is no exception, then this exception object will be null, and if it's not the case, there will be something with it. So I can decide to create a new result, for instance, that is null. For instance, if I do not have the forecast and I can live with no information on the forecast, I can just call the set forecast with a null object. I could decide to do that. And I also a when complete method that instead of a B function takes a B consumer that will not return anything, and that is another way of handling exceptions. So in fact, I've got 3 ways of handling exceptions with the CompletionStage API. So here is what it's going to do. Here is the pattern we just wrote. We apply it until the unmarshal quotation, for instance, object. Suppose we have an exception, all right? We could say, all right, we got an exception, so we take it with this exceptionally method. If there's no exception, this exceptionally call will not do anything. It will just be transparent in the chain. And decide, in fact, that if an exception is raised, well, it's not too bad. The quotation will be null for this object. So I can still set a null value for the property quotation of my destination. And this time, my completion stage will not be in error anymore, thanks to the use of this exceptionally method. I could also decide to use the handle method. The pattern is not that nice because I've got this if then else in it, and since I am in a world of lambdas and functional programming, the if then else doesn't really fit very well in this world, I think. But hey, you can still use it if you like it. So if throwable is null, it means that I do not have any exception, so I can just set the quotation like that. If it is null and I decide not to do, well, I will need to make a decision on what to do with this destination object. All right.
Okay, so you've saw some examples using the new RX invoker that is now part of JAX-RS 2.1. You saw that for all our example, we have been using the HTTP GET method, but it works for all the HTTP methods which are supported by the client API of JAX-RS 2.1. So that's delete, get, head, option, and so on. So basically all the HTTP methods but patch, because patch is not supported by the client API. Now, so what we have discussed today is also how you can basically leverage JAX-RS 2.1 with the CompletionStage API, which is part of the Java AC8. Now, we also acknowledge that there are other reactive API in the market. So the JAX-RS 2.1 specification has been written in a way so that, I mean, it's mandatory to support the CompletionStage API, but it's also open to third-party API. So any JAX-RS implementer can decide to support, in addition to the CompletionStage API, other reactive API. And if you look at Jersey, which is the JAX-RS 2.1, well, which is the JAX-RS reference implementation, we do support, obviously, the completion stage. That's something that we have to. But we also support the Guava listenable feature, and we also support RxJava and RxJava 2. So the way it works, so if you want to use, let's say, for example, the flowable, you first have, when you construct your client container, you need to pass it a specific invoker provider for that API. In this case, it's a Rx flowable invoker provider, so you pass it that class. And then when you do the request, you need to pass that specific invoker to using the Rx method. and there you go, you can then use that specific reactive API. So basically, we could use the pattern that we have discussed today with the CompletionStage API, but you can also use that way of thinking, but using the specific reactive API that are in the market. Again, this is optional, but that's something that we do in Jersey. Now, let's quickly talk about CDI. I mean, what's the link between JAX-RS and CDI? Well, in Java 8, we have released the CDI, GSR 365. And, well, CDI 2 is addressing quite a lot of is adding quite a lot of new stuff, but one of the things that CDI 2 is adding is asynchronous event. So you know that in CDI, we have since the beginning this nice event mechanism. So you have this producer-consumer patterns implementation that basically allows you to easily produce event in your application that will be consumed somewhere else in your application. The thing is that until CDI 2, that was purely synchronous. So basically, you were consuming the event in the same thread as the producing thread. This is not true anymore in CDI 2, so we now have the ability to raise and consume asynchronous event. So the way it works exactly the same way. So we are injecting an event of a given type, and then in CDI, well, if it would have been a synchronous event, we would have invoked on that event the fire method. Given that it's an async event, we are invoking the fireAsync method. So it's a new method in CDI 2. So this is the producing side. So basically, I'm producing an event here, and obviously, somewhere else, I will want to consume that event. To consume that event, I just have to define an async observer. So for that, I have a method that is using this new @observes async annotation, and at any time, an event will be fired by that producer, my observer will be invoked in a different thread in an async fashion, in a fully async fashion. So that's something which is new in CDI 2. And you see that when we are firing an event, what we get in return is a completion stage. So that basically means that we can combine the completion stage that we have discussed with JAX-RS before with that completion stage object as well. So that's basically the link between the two API. Now you have the ability to pass an executor services. So that's something that is done when you fire the event. You take that one or? Yeah.
So basically, when you are saying that you want to execute something asynchronously and do not provide an executor service, it will get invoked, in fact, in the common fork join pool of the Java 8 virtual machine. But you also have the possibility to pass an executor as a parameter to make sure that your tasks are going to be executed in that executor. And this is especially useful in the CDI world, where, for instance, you have a system that is going to fire an event, and this event is supposed to update some kind of swing panel or JPEFI effects panel, or if you're in the Android space, some kind of human interface panel. And you know that in order to update this kind of component of graphical component, user graphical interfaces component properly, you need to execute that code in a special thread, in a special executor. So you can pass an executor as a parameter here, and this is really mandatory when you want to do that. For instance, swing utilities can invoke later is an implementation of the executor interface. Might look quite odd, but it is the case. And you can pass that to make sure that this payload is going to trigger the updating of a swing panel, for instance, in the right thread. And this is why it has been added in CDI 2. And I think it's time to wrap up.
Yeah.
Have a go.
So, wrap up time, right on time.
Yeah.
Unbelievable. So today we have discussed about the JAX-RS 2.1 API and the CDI 2 API. Those API are part of a larger effort that is Java 8, which was just finalized 12 days ago, 21 of September. There are quite, well, next to that there are quite some nice stuff in Java 8, like support for HTTP2, the servlet API. Support for JSON-B. In some of our codes, we have using the JSON-B API that allows us to easily unmarshal and marshal Java object and JSON document, and so on and so on. So the nice thing about most of those API is that they can, obviously they are part of the Java 8 platform, and they can also be used outside of the Java 8 platform. And that's basically what we have done today. The only thing is that if you are using the completion stage within the Java 8 platform, you need to pass manage executor services, because the container has to basically manage the thread that will be used. So with that, we have like 2 minutes for questions. So, yes, sir.
Is this stuff available in SE outside of an EE container?
Yeah, JAX-RS, you can use it on top of Java-C. That's what we have been doing here. So JAX-RS, JSON-B, servlet, JSON-P, CDI, bin validation. GSF is kind of tricky, and security is clearly the only API which is Java-E only. So yeah. Yeah, and forgot to mention that the CompletionStage API, which is basically the core of our talk today, is Java-C. Yeah. Yes?
You mentioned that JAX-RS, your pipeline, allows you to return completion stages from your REST handlers, and is that guaranteed to be executed in a non-blocking fashion by the container and then
At some point,
repeat the question.
yes, I'll repeat the question. It was about the fact that when you return a completion stage in this JAX-RS method, you want to make sure that it is still executed in an asynchronous fashion, right? Okay. So the answer is, in fact, by essence, the task wrapped in a completion stage is executed in a thread either of the executor service you've passed as a parameter, because you can pass an executor as a parameter when you create the task, or when you call the then apply, then accept, then compose, etc. Right? Or in the common fork join pool of your Java 8 virtual machine. Okay. So this is guaranteed because this is how the Java AC8 completion stage completable future stuff works. Now, at a given point, you need to have the result of that, all right? And you have to wait for the result to get it. So this has to be made synchronously, okay? You can only provide the result to the client once this result is available. So at some point, you will fall back on some kind of synchronous call. But this synchronous call is triggered asynchronously by the API itself. That is, it's triggered when the result is available. You do not have to wait yourself. This is handled by the API. I don't know if it answers your question. Yeah? Okay, thank you. Any other questions? Come on, don't be shy.
Well, then we will give you 1 minute back. So we would like to thank you for coming here. We hope you enjoyed it. And please make sure to leave feedback when you leave the room. Thank you.
Thank you very much.